Hello and welcome to Mad Science Gaming, emphasis on science through gaming. What I have for you is a video made as a part of my electron microscopy course at San Joaquin Delta College. It explains the basics of electron diffraction as observed through a transmission electron microscope, or TEM. I hope you will walk away with new knowledge and enjoy.
So, yes, electron diffraction. Basically what's happening is you have your electron beam and it's splitting, much like a light that goes into a prism splits into a rainbow. Only this time it's not splitting because of different speeds of the colors of light, being different wavelengths and all. This time it's because of, unlike the beams of light in prism, with electron diffraction, you have these planes of atoms because you have a crystalline material. In fact, it only works with crystalline materials. So then you have your electron beam, and most of it just goes straight through in between the planes of atoms. But some of it bounces off and goes in at a certain angle in a certain direction. And all of these together make one of the spots, like one of the spots right here. Only because it's a lot less likely for it to hit that specific angle than it is to look at all that space in between that it can go through. Because of all that space, that's why you'll have the dot that's straight down under the beam be your biggest spot. Because normally in the TEM we have an aperture here that blocks out all these other spots. So we're left with just this spot in the middle. So you have these apertures, and what they'll do is they'll remove all of these other spots. So you're left with just that one. And when you have just that one, normally you use the electromagnetic lenses and spread it out and make a big picture, like that, roughly. But in diffraction, you don't magnify anything. You just leave it as is and let all the spots occur. So actually, if you took an aperture and say you just wanted to, say you just said, oh, I want just this spot right here, please. So that would take away all of these other spots, and you're left with just that one. But you see, the thing is, because that spot only exists because of the sample going that spot will be exactly like dark field in a light microscope, where the background will be a little bit darker and the sample will be a bit brighter, because only the electrons that are bouncing off of the planes of atoms in the sample go to that spot, and that's TEM dark field for you. So that's the basics of what diffraction, not how it works, but what it is.